In this video, we're going to look at how to graph quadratics in two different forms, vertex form and standard form. So just as a reminder, we spent a lot of time using parent functions previously to graph quadratics. So remember for x squared, we had these parent values. So if we had our xy table, we used x values of -2, -1, 0, 1, and 2, and those produced y values of 4, 1, 0, 1, and 4. So on our graph, that looked like this. So we had -2, 4, right here, -1, 1, 0, 0, 1, 1, and 2, 4. So this was our parabola. And then we used our parent function. We looked at these transformations. So this -1 moved everything to the right 1, and this +3 shifted everything up 3. So we just took those 5 points, moved everything to the right 1 and up 1, 2, 3. So here are our new points, and here was our transformation of our graph. Now we're going to look at some different forms that we can write quadratic equations in, and one is vertex form. So that looks like this: f of x is equal to a times the quantity x minus h squared plus k. And this form is useful because it gives us some important pieces of information. First of all, the vertex of this graph will be at h, k, and the axis of symmetry, which in a minute we'll abbreviate, is at x equals h. So what's important to notice is that this is subtracting h, minus h. But when we're looking for the vertex and the axis of symmetry, we're ignoring the fact that that was subtracted. So if we look at these two equations I've written below, we can tell two things. So first of all, we can tell the vertex. So here's h and here's k. So h is 2, and then k is -4. So the vertex is at 2, -4. And then the axis of symmetry will be at x equals 2. Now, in the second one, you'll notice we have an addition sign here. So the only way we could get an addition sign when we know the formula was supposed to have a subtraction sign is if we subtracted a -3. That would become a plus. So what that tells us is that h is -3 this time. So this time the vertex is at -3, and then k is +1, so -3, 1. And the axis of symmetry is at x is equal to -3. So in the past, we've actually worked with finding x and y intercepts, but we're going to do it again here. So remember, to find the y-intercept, we are going to replace x with 0 in the equation. And so we'll end up with a y-intercept at 0, some value. And this is going to be our y-intercept. Now for our x-intercepts, we were just doing this when we were solving equations. We are going to set the equation equal to 0 and solve. And so remember, we talked about how the x-intercepts are sometimes called the zeros. So that is what we're finding here. So remember, we've talked quite a bit about standard form of a quadratic equation, and that is ax squared plus bx plus c. So in this form, we can't just look at it and know the vertex and the axis of symmetry like we can if it's in vertex form. So there's a way that we can find those, however. So to find the vertex, remember there's two coordinates to our vertex, an x coordinate and a y coordinate. So to find the x coordinate, we're going to use actually part of the quadratic formula, the opposite of b over 2a. This gives us the x coordinate of the vertex. So once we know x, to find the y coordinate, we plug x into the equation. And so that's this x that we found right here. So once we plug in x, it will give us the y coordinate of the equation. Okay, so here's an equation in standard form. So let's walk through all the steps. First of all, we notice that the coefficient, the leading coefficient, is a positive 2. So we know that means our parabola is going to open upward. So if we somehow get a parabola that's not opening upwards, then we know we did something wrong. The next thing we're going to do is find the vertex. So remember, we use x is equal to the opposite of b. So in this case, b is negative 8. So we will use the opposite of that. We will use 8 over 2 times a, which is 2. So this gives us 8 over 4, which we can divide to get 2. So this is the x coordinate. But now what we need is the y coordinate. So we're just going to plug in 2 for x. So 2 times 2 squared minus 8 times 2 plus 8. So this gives us 8 minus 16 plus 8, which is just 0. So our vertex is at 2, 0. So that's one piece of information that we will need. Now remember that whatever this x value is, that's the same thing as our axis of symmetry. So our axis of symmetry is a line, and it is going to be at x equals 2. So now we have two other things that we need to find. We need to find the x-intercepts and the y-intercept. So let's find the y-intercept first. All we have to do is replace x with 0 in the original equation. So when we do that, we get 8. So our y-intercept is at 0, 8. And then finally, we need to find the x-intercepts. So remember, we're going to take our equation, set it equal to 0, and solve. So we're going to solve by factoring. Notice I can factor a 2 out of everything, so that will leave me with x squared minus 4x plus 4. So then I can factor this trinomial right here. This will factor into x minus 2 times x minus 2. So these are exactly the same here. So when we solve, x minus 2 is equal to 0, which means we just have one x-intercept at 2, and that is it. So now we can take all of this information and we can start plotting it. We know that our vertex is at 2, 0, so right here, which also happens to be our only x-intercept. We know that our axis of symmetry is at x equals 2, so it will always go right through your vertex. We know that our y-intercept is at 0, 8. So that's right here. Now remember, these graphs are symmetrical. So if I have a point that's 1, 2 spaces to the left, I also have one that's 2 spaces to the right of this axis of symmetry. And so now I have everything graphed. I can go ahead and I can connect these 3 points, and there is my parabola. Okay, so same thing with this next one. First of all, our leading coefficient here, A, is positive, so we know that this will also open upward. And then we're going to move on to finding the vertex. So we'll start with the x-coordinate. X is equal to the opposite of B, so -6 over 2 times A, which is 3. So -6 over 6 is -1. So that's the x-coordinate. To get the y-coordinate, we'll simply plug that in. 3 times -1 squared plus 6 times -1. So that gives us 3 minus 6, which is -3. So our vertex is at -1, -3. And remember, this is also our axis of symmetry. So our axis of symmetry is an equation because it's a line. It's at x equals -1. So now that we have those, we can find our y-intercept by simply replacing x with 0. So when we do that, everything just becomes 0. So our y-intercept is at 0, 0. And then to find our x-intercepts, we're going to take our equation, 3x squared plus 6x, and we're going to set it equal to 0. This is one we can factor using GCF factoring. So 3x times x plus 2 is equal to 0. So either this 3x is the 0 or this x plus 2 is the 0, which means my x-intercepts are at 0 and -2. So again, I'm going to use all of that information, starting with the vertex at -1, -3, so right here. My y-intercept is at 0, 0, which is also one of my x-intercepts. My other one is at -2. My axis of symmetry is at x equals -1, so again, it has to go right through that vertex. So now I can take those 3 pieces of information on my graph, connect them to make my upward opening parabola. Okay, this last one has a negative leading coefficient, so this one is going to open downward. So same thing we've been doing. Next we're going to move on to our vertex, and we're going to start by finding the x value. So we need the opposite of b, so -12 over 2 times a, which is -3. So -12 over -6 is equal to 2. So remember, this is x. Then we're going to plug that in to find y. Y is equal to -3 times 2 squared plus 12 times 2 minus 9. So if we start computing all of this, this here gives us -12 plus 24 minus 9, which is 3. So this is the y-coordinate. So our vertex is at 2, 3. And again, that tells us that our axis of symmetry is at x is equal to 2. So those are the first 2 pieces of information. And then we're going to move on to our y-intercept, which means we're just going to replace x with 0. So negative 3 times 0 squared plus 12 times 0 minus 9 is negative 9. So our y-intercept is at 0, negative 9. Then all we have left are the x-intercepts. So we're going to take our equation, negative 3x squared plus 12x minus 9, set it equal to 0, and then we're going to factor and solve. First thing I'm going to do is factor out a negative 3. That will leave me with x squared minus 4x plus 3. And then I can factor this trinomial further. It will factor into x minus 3, x minus 1 is equal to 0. So again, only the things with variables could be the 0. So either x minus 3 is the 0 or x minus 1 is. So my x-intercepts, if we solve, are at 3 and 1. So now I can use all of those pieces of information to make this graph. My vertex is at 2, 3. My axis of symmetry is going to go right through that. I have my y-intercept at 0, negative 9, so way down here. Now again, this is 2 spaces to the left of my axis of symmetry, so I know I also have a point 2 spaces from the right. Then I have those intercepts that we found, so those are at 3 and 1, and you can see that my x-intercepts are also the same exact distance away from my axis of symmetry. So that's how I know they're right, and then I'm just going to connect those to make my downward opening parabola, and there is my graph.